Okay, so let's start, continue our discussion. All right, so we are going to talk about function. Now, what is a function? Now, function is actually a process. So this is a process, okay, or operation. So this operation, we assign one input to one output, okay? The input, we call this as X, and the output is, we call that Y. Now, for example, let's say we have this function is X plus 1. Okay, now for example, all right, so you have, let's say you have one pen, okay, inside your pencil box. And today, you actually go to the bookshop to buy few pens, okay, to buy few pens. Now, how many you buy, you are not sure yet. So we use the X to represent the quantity of new pens you are going to buy. Okay, so now the total, this is the Y. The Y is the total pen you have now in your pencil box. So the total pens you have will be the pen you buy today or the pen you bought plus 1. Okay, this one is the pen you have now, right, existing. So this is the pen that you are going to buy later, right? This will be the total. So now, what if the X is 1? What do you get for the Y? It will be 1 plus 1, right?
Yes.
Okay, so then it will be 2. Now, so from here we can see, so when we have the input is 1, then after this function, all right, we have the output is 2. Okay, so the 1 refer to the pen you buy, and the 2 refer to the pen, the total pen you have. So if you buy 10 new pens, okay, you buy 10. So what is the Y? It will be 10 plus 1, it will be 11. So, right, the input is 10. Then after this function, you will have 11. Now, is that okay? All right, so what is a function? A function is an operation, or we say a process, to assign one input to one output. Okay, the X here, we call this independent variable. Okay, because the X is what we are going to decide. This X is what we are going to decide. And the Y is called the dependent variable because, okay, after we decide the X, right, we are going to get the Y. So the Y actually depend on the X. We call this dependent variable. Okay, right, so this is the definition of function. Now let's take an example to understand this better. Okay, now, did you ever take taxi before? Do you have the experience taking a taxi ride?
Yes.
Yes, right?
Yeah.
Yes.
Yes. Okay, now when we take a taxi, we have the base price. This price is the price that we are going to pay once we get on the taxi. Okay, so when you get on the taxi, the base price, all right, $5. Now, and this is the charges or the cost per kilometer per km. So for each km travel, so you are going to pay $2. Okay, now the first question is, now what is the price you need to pay if you travel 7 km? How do you calculate this?
7 times 2.
19.
19, good. So how do we calculate? So first we are going to take $2 multiply 7 kilometers, right? Because each kilometers, we are going to pay $2. All right, so 7 kilometers multiply $2 plus the base price. Okay, so the answer is 19. Okay, so from here, now based on the concept we have, the function, now if this is the input, the key input is the km, the distance. Okay, the input is the distance and the output is the price. So when the input is 7 km, so after this function, all right, the output is 19, which is the price that we need to pay. So are you okay with this idea?
Yeah.
Yes.
Yes, yes.
Very good.
Yes.
Clear.
Yes.
Okay. So now we are going to write the function here. Now let the function be fx. So if we travel x km, therefore, according to this calculation, we are going to take the x km, multiply $2 plus the base rate of $5. So this will be the function. And this function assign the input, kilometers, the distance, to the output, the price. Okay, so let's continue. Now we are going to learn the linear function. There are actually many functions. So the first one we are going to learn is called the linear function. Okay, the linear function, if we draw the graph, the linear function will be a straight line. All right, so if we actually sketch the graph, the linear function is actually a straight line. Now the linear function is always in this form. Remember the previous one? All right, for this function here, all right, it is 2x plus 5, right? So this function is actually a linear function because this function is in this form, is mx plus b. Okay, we have 2x plus 5. So the m and the b, they are actually numbers. Okay, they are actually numbers. We call this constant. Okay, now the m and the b, they are real numbers. For m here, we call this a slope. And the b, we call that y-intercept. Okay, now any questions here? Now, in the following discussion, we are going to learn how to find the m and how to find the b. Okay, so let's go on. Okay, now example, write an equation to represent the situation. Okay, now the cost y is the cost to purchase a car of 20,000 and drive it for x km. If the cost amount is 80 cents or $0.8 per km. So how do you actually write the cost? Okay, perhaps maybe you try it. Okay, can you try it and type in the message box? How do we actually calculate the cost? Now the y is the cost, the cost. To own a car, now to own a car or to use a car, first you need to buy the car. So when you buy the car, when you purchase the car, it is 20,000. So after you purchase the car, you drive for x km. For each km, you need to pay $0.8 or 80 cents. So the cost will be 20,000. This is the cost you pay for the car. And 80 cents for each km you travel. All right? So this is the function we have. So this function allows us to calculate the cost we need to pay, right, to use a car. All right, so Imagine if you travel for 100 km. If you travel for 100 km, what is the cost you need to pay? What is the cost you need to pay?
Mm,
All right, it will be
20,800.
20,880.
80.
80. All right, good. All right, so we will take this one, multiply. All right, 0.8 multiply 100. You have 20,080. So we use this function to calculate the cost, right, to use a car. All right, so now this example actually illustrate, okay, the linear function. So the linear function, okay, can be written in the form of mx plus b. Okay, mx plus b, where the m is a number and the b is another number. Okay, now this is the application of a linear function in the real world. Okay, the application of linear function in the real world. So I'm going to spend some time to explain it. Okay, now first, now how many of you have the experience of doing business? Do you have a so-called chance to involve in a business before?
Not me.
Roughly, okay, good. Now, okay, when we involve in a business, we have these three terms that we need to know. Now, the first one is called revenue. The second one is called a cost. And of course, maybe the most important is the profit, right? Profit. Okay, now let's see. Okay, what is revenue? Now, the revenue is actually the income from your business. Okay, this is the income from your business. All right, now let's say, for example, let's say you are selling some products. Can you give me an example? What are the products that you are selling? Sorry?
Tea.
Tea.
Yeah.
Okay, tea. Yeah? Okay, good. Now let's say you are selling tea. We say a cup of tea. Yeah? All right.
Okay.
So, what is your selling price?
It's $5, for example.
Okay, good. Let's say you are selling it for $5.
Okay.
Okay. Now, in a particular day, let's say the quantity,
Okay.
right, is, okay, can you give me some example? Okay, what do you want the quantity be?
It's 100.
100, good.
Okay.
Now, let's say in a certain day, the quantity is 100. Now, how do you calculate your revenue? All right, your income.
Revenue? Yeah, quantity times price.
Very good. It will be $5
Yeah, times
per
100.
cup, multiply 100 cups, right?
Yeah, yes.
So it will be $500.
Yes.
Okay, so now in the business, right, we calculate revenue by using the selling price multiply the quantity.
Okay.
Okay, now can you see here, this is actually a linear function.
Yes.
Okay, we have y equals to mx plus c. Okay, what is the
Yes.
c here?
C is we don't have.
Okay,
Zero.
we don't have. Yeah, very good. We say it is 0.
Yes.
Okay, so now this is a linear function. All right,
Okay.
the revenue will be $5 multiply the quantity plus the c, okay, or plus the b. Okay.
Yeah.
Here we actually use the symbol b here. All right, plus
Yes.
the b. So the b is
0.
actually 0.
Yes.
Okay, so this is the first concept. All right, this concept, revenue, we use a linear function to solve. Now, the second concept is called the cost.
Yeah.
Okay, now, for example, let's say we are selling t-shirt.
Okay.
Okay. Okay, now for this t-shirt, right, we talk about the cost. Now, to produce one t-shirt, actually the cost is very low, all right, because the material, right,
Yeah.
the material might not be very expensive. So for example, to produce a t-shirt, right, the cost may be $7.
Okay.
Right, we are talking about the material only. Okay.
Okay.
Now, so we call this the marginal cost.
Yes.
Okay, the marginal cost is the cost to produce 1 unit of product. 1 unit of product. We call this the marginal cost. Okay, now let's say you receive an order, all right? The quantity is 1,000 t-shirts, unit of t-shirts.
Okay.
Okay, so what is the production cost?
7,000.
It will be,
7,000.
yeah, good. The production cost will be $7. Multiply 1,000 units, it will be $7,000.
Yes.
Okay, this is what we call the production cost. Now, this is the one. Production cost is the variable cost, or we say the marginal cost, multiply the quantity. Okay, are you okay with the concept at the moment?
Yes.
Okay.
Yes.
So marginal cost is the cost per unit of product. When we multiply with the quantity, so this will be the production cost. Now, beside the production cost, we also need to calculate the fixed cost. We have another type of cost, it's called the fixed cost. Now, the fixed cost, it means that whether you do a business, whether you have business or not, you need to pay for it. Okay, now for example, now Malaysia, all right, last few months we have something called a motion control order. Do you know what is that? I'm
Is
not
it
sure whether. Yes.
about tax something?
No, motion control order is because of this pandemic, COVID-19, we are restricted, all right, to go out from our house.
Yes.
Okay. Now we call that MCO, motion control order. So during that time, the shops, they are not allowed to open. The business, all right, they are not allowed to do business. Okay. Now, however, now when business are not allowed, no business, no business, there's cost incurred. Okay, can you give me some example? What are the costs incurred even you do not have business? For example, rental, right?
Really? Yeah, rental, delivery.
Yeah, labor, or we call the wages. All right,
Yeah.
now the salary. Okay, the salary we
Yeah.
pay to the workers.
Yes.
Okay, for example, the insurance.
Insurance.
Right, now all these are the fixed costs. Now, even we do not have any business, all right,
Yes.
so we still need to pay for the cost. This is called the fixed cost. Okay, so therefore for the cost, all right, we have the fixed cost plus the production cost. Okay, now back to this example here. All right, now selling t-shirt. Now the cost, okay, let's say the fixed cost is $10,000 per month. Therefore, all right, the total cost will be $7 multiply the production, the quantity of the product plus
10,000.
5,000. Very good. All right. I believe you get the concept.
Yes, yes.
All right. Now, at the moment, do you have anything to ask? Do you have anything to ask at the moment? No. Okay. Now you can ask me later if you think of one. Okay. Somebody say something, right? Sorry, I didn't hear it well.
No problem. Just
Okay.
actually everything is clear. Okay.
Okay. Thank you very much. All right. In case you think of one or two questions, you can also ask me later. Okay. Now come to the third concept. Is called the profit. Now the profit, of course, is the revenue minus the cost. Okay. So when we take the revenue here minus the cost, then we have the profit. I believe this one is very clear and simple. Okay, now let's see. We have an example here. Okay, now can you actually try this example? Right, we take maybe 1 or 2 minutes to try this one. So I'm going to provide the answer together. Okay, so that we do it together. Okay, so there is a firm. It has a fixed cost of $3. So the production cost is $0.2 per unit. Okay, so this is $0.2 per unit, and the selling price is $5 per unit. So we're supposed to write the function and form the profit function as well. Okay, so now according to this one, first we calculate the cost. Okay, so the cost, let me put the C to represent the cost. Okay, so what is the cost function?
0.2. No, 3.
0.2 is this is the cost per unit, right?
Yes.
So what is X? Good. Quantity.
0.2.
Plus 3.
3.
3.
Yeah.
Okay, very good. Okay, so I also see some of you writing the answer on the chat box. Okay, you can do that as well. So this is the cost function. All right, so for 1 unit product, the cost is 0.2. And we multiply the quantity, this will be the total production cost, plus $3 is the fixed cost. All right, now next, how about the revenue? The revenue is the income from the business. So we put it as R. So it will be $5.
5Q.
5Q, you are right. Okay. All right. Yeah, I'm supposed to use the Q instead of X. All right. So the question says use the Q, all right, as the quantity. All right, selling Q units of product. So this is the revenue. And how about the profit? Now the profit will be the R minus the C. We'll have 5Q minus 0.2Q plus 3. And therefore, we have 5Q minus 0.2Q minus 3, 4.8, Q minus 3. Okay. Right, is there any questions here?
No,
right?
no.
Yeah,
No,
5Q
no
minus 0.2Q
No.
4.8. Okay, let's move.
Oh.
Okay, now, so these are some example of a linear function. Okay, so now come back to here. Now we know that for linear function is always in this form. And okay, we need to now move on to the slope. Okay, the M is the slope and the B is the y-intercept. Okay, so we are going to discuss these two, all right, in the following discussion. Now, what is the slope? The slope is actually the difference of y divided by the difference of x. So this is actually a ratio. Okay, so what is the difference of y? Is actually here, right? This is the difference of y, right?
Yeah.
Right, so when we have 2 points, so this represents the difference of y, and here represent the difference of x. Okay, so now how to find the difference of y? We are going to take y minus y. Okay, how to find the difference of x? We are going to take the x minus the x. Okay, now this is the formula we are using here. Okay, this is the formula we are using. So I just want to highlight to you that this is actually 1 point. Now x2, y2 is 1 point and x1, y1 is another point. So we always write the point in this way. Okay, when we have 2 points, we want to find the slope, we will write the 2 points in this way. Okay. Now, for example, let's say for this function, when the x is 0, so the y will be 3, 0 plus 2. So we have the y is 2, right? So we have 1 point here. This is 1 point. Right, the x is 0, the y is 2, so we have this. Now when the x is 1, what is the y? It will be
5.
Yeah, good.
8. 8.
3 times 1?
5.
Plus
5.
5. Yes, it's 5. So then we have 1, 5 is another point. Now, when we use these 2 points to calculate the slope, so this is what we do. First, okay, this one, there should be 1 point. So I'm going to write, this is the y, and this is the x. So 5 and 1. Okay, minus. This will be another point, so I'm going to use the other point. What is the y?
2.
2. And the
2.
x is 0,
0.
right? So I have actually 3 over 1 here. Is that okay? And
Yes.
then the slope is 3. So you can see this is actually the slope. Okay, so the slope, we can actually use 2 points to find. Now, actually, for this example, we have the slope, we have the y-intercept. Okay, we have the slope, we have the y-intercept. We are actually using this function as an example to create 2 points and to find the slope. Okay, all right. So now, when the slope is 3, right? This is a positive value. Now it means that, okay, this is important. It means that now when the x is increased by 1 unit, or should I write like this? So when the x is increased by 1 unit, okay. Now, how do I know the x is increased by 1 unit? This is the 1. Okay, the difference of x is 1. So it means that when the x is increased by 1 unit,
Yes.
now what happened to y? The y is
Increased by 3.
increased by 3 units. Very good. So this is how we actually understand the slope. Okay, when the x is increased by 1 unit, the y increased by 3 units. Okay. Now the intercept. Okay, the intercept is actually the point where the graph crosses the axis. Okay, so we have, now in a graph, how many axes we have? How many axes we have? Or how many axes?
We have 2.
2, right?
Yes.
What do we call this one?
X-axis.
Intercept and axis.
Yes, x-axis. And what do we call this?
The y-axis.
Y-axis, right? So this is the x-axis and this is the y-axis. Okay, now when we have a slope like this, okay, when the graph is like with a function like this is the point where the graph crosses the y-axis. So we call this the y-intercept.
Yeah.
Okay, I'm using a short form, y-intercept. All right, because the graph crosses the y-axis. And then, of course, this one will be the
X-intercept.
x-intercept.
X-axis.
Okay. Now, so from the graph here, we know that for the x-axis, what is the value of y at this point? What is the value of y?
0.
0.
Good. So
Zero.
the y is 0 at x-intercept. Okay. At the x-intercept, the y is 0. And therefore, okay, we have, okay, to find the x-intercept, we have, okay, 3x minus 5y. The y is 0. All right, we are going to put a 0 here, equals to 15.
5.
And 3x is 15, then the x is
5.
okay. Now, how about for y-intercept?
That's when the x is equal to 0.
Yeah, the x
Sweet.
is equal to 0. We are going to replace the x with 0. So we have 3, 0 minus 5y equals to 15. So the y will be 15 divided by negative 5.
Negative 3.
Negative 3. Okay, so in this case, now this is the x-intercept and this is the y-intercept. Now, I actually know that the graph will be, okay,
Down.
yeah. Now the y-intercept is negative 3. The x-intercept is 5. So this is the function. This is the graph of the function. It's supposed to be a straight line. Please assume it's a straight line. Okay, my line is not straight. Okay, now so this is one is for illustration only. Okay.
Yeah.
So this is actually the graph. Okay. Any question at the moment?
Nothing.
Good.
No.
Now, so at the moment, okay, so far we discussed the slope and we discussed the intercept and especially the y-intercept has two components for the linear function. Okay, has two very important components for the linear function. Okay, now let's consider this example. Okay, do you know what is a scuba diver? Do you know what is a diver? So this is
Yes.
the sea
Yes.
level. Sea level. So the scuba diver is those who like to go under the water
Yeah,
or
I
under
actually
the sea.
thought about it before.
Yeah. You need to get a license to do this. Okay, so it's not snorkeling. Snorkeling, everybody can do that, but to be a scuba diver, we need to obtain a license. Okay, now we have a table here. This table tells us the time and the position of the scuba diver. For example, when the time is 0 seconds, what is the position?
24.
Minus 24.
Yeah, negative 24. What does that mean? It means that it is 24 meter under the sea level, under the water. Is that okay?
Yeah.
Yes.
So now, then according to this table, when the time is 12 seconds, okay, the scuba diver is actually on the surface of the water. The depth is 0 meter. Okay, the scuba diver is here after 12 seconds. All right, now if we are actually finding the intercepts, okay, can you tell me which one is the x-intercept?
Time.
Okay, which one is the x-intercept?
Time.
Time is? So,
X.
okay, this one is the time, right?
Yes.
Okay, so when to find the x-intercept, we're talking about the x-intercept.
Yes.
So what should I do to find the x-intercept? What should be 0? What should be 0 here?
Y.
Y.
Okay, good. The y should be 0. Therefore, all right, we are looking for y. This is the y. This is the x. So the y 0. So then the x-intercept is 12.
Yes.
Is that okay?
Yeah.
Right?
Yes.
So the y should be 0, right? The depth of the scuba diver should be 0, and we have the time is 12 seconds. And of course, the other way around to find the x-intercept.
When x is 0.
All right, the x is 0, correct. So, and the y-intercept is negative.
24.
Okay, so it will be here, negative 24. This is the y-intercept. Now, do you have any question to raise for this discussion here?
No.
No.
Okay, good. Right. All right, so I'm going to skip this one. Okay, now after we learn the linear function, okay, what is the form of linear function? We say the y is equals to?
mx plus b.
plus b.
Okay, good. So what is the m?
Slope.
Real number.
The gradient.
Real number, correct. The other gradient, yes. So it's a slope. And how do we find the slope? We take the difference of y over difference of
X.
x. Okay. So what is the b? Y intercept. So at this point, y-intercept, what is equals to 0?
X equals.
X is 0.
Yes, x. All right, x is 0. Okay, so now in the following discussion, we are going to discuss how to sketch the graph of this linear function. Now, before that, do you need a short break for 5 minutes?
I don't mind.
Sure.
Yeah.
Yeah, I think we take a short break for 5 minutes. Okay.
Okay.
And, all right, we will come back at 408.
Okay.
5 minutes after this, all right, you can actually calculate according to your time.
Yeah, 407.
Yeah, all right, so see you later.
Okay.